Okay, so this is about these are tables. These are tables, huh? And this table, I just want to mention one more time is this is the selected choice of fittings. In practice, you have hundreds more choice of fittings available, because here, just for illustration, we select 10 of fittings. Doesn't mean in real life only 10 kind of a fitting available for us. For the international standard, we have hundreds, even thousands. Basically, there's one book you can refer to. You can select very precisely what kind of fitting you want. Okay. So engineering is about, let me repeat, it's about the details of it. What we try to do for this topic, have some basic understanding about the fit and the tolerance. So there's some questions here we need to go through. We quickly go through. Okay, so the purpose of a control dimension, the control tolerance, allow interchangeability. We can produce the parts from company A and company B. You can mix up because they are all following the tolerance, same tolerance. So whether it's a control produced by company A or B, interchangeable. You can buy a screw from another company, nicely fitting, because everybody following a tolerance, right? And the tolerance basically is a way to control the dimension, and we can achieve the assembly what you want. You can have 3 conditions. Remember, clearance, transition, interference. So there's some terminology here. Terminology, they say, okay, nominal size 20. Okay, when you create a CAD model, you use precisely 20. Right? But when you come to manufacturing, you need to specify upper limit, lower limit. Means, for example, this dimension, and you have to follow 45 plus minus 0.15 minus 0.2. So actually the limit, lower limit is 44.8, upper limit 44.85. Normally in the drawings, we will use this way to specify, very clean and neat way. But we understand the lower limit is like this, the upper limit like this. Okay, so they write these two because very clumsy, not so easy. And then the QC job basically to check each of our individual parts within this range. Okay, so this tolerance can be one direction, can be bi-direction, doesn't matter. Okay, so not critical, huh? And there's a term we call deviation. Deviation means that the actual size minus the basic size. We have a specification of the tolerance, right? There's upper limit, lower limit. So when you machine out real pieces, say 19.95, then compare with the nominal size, the deviation is minus 0.05. So counter check with the upper limit, lower limit. Is it this part acceptable or not? Hello, class? Is it this part acceptable or not?
No.
Minus 0.05. I have a tolerance plus 0.2 minus 0.15.
Oh.
Is it acceptable or not? So there's a range. I allow you the dimension to be deviate on the plus side maximum 0.2. On the negative side minus 0.15.
Oh, so it is acceptable.
So essentially it's not acceptable.
Oh, see.
That's the QC job, because the QC need to check and see your actual work pieces. You pick it up and then measure. It's the minus 0.05 difference. And I allow you minus 0.15. Okay, good. So this one is acceptable. And who specify this one? Plus 0.2 minus 1.5. Your job. Your designer specify. And why do you need to specify? Just now I mentioned, we want to achieve certain fitting conditions. Right? Okay, there's a 3 kind of a fitting here. Minimum clearance fitting, transition fitting, interference fitting. Okay, there's a, when you come to the clearance fitting, so we need to find out what is the minimum clearance, what is the maximum clearance. This is the probability, means I have a specification for hole, I have a specification for shaft. So what is the likely maximum clearance? What is the likely minimum clearance? In real life, the actual clearance will be between these two extreme pieces. Right? Same thing for the interference. When you do the calculations, it's always the hole minus shaft. So don't use this formula. So for example, maximum clearance, basically the hole is a max minus the shaft is a minimum. When you want to find out the minimum clearance, okay, so the hole is a minimum size, minus of the shaft is a maximum size. Okay, so you later I will show you one example. Okay, the fundamental deviation is basically sounds very hard to understand. Basically to show this tolerance how far away from the basis size. Because the tolerance I can be the same, but I can move away up and down, up and down. And in the international standard, this deviation, fundamental deviation, will be represented by a letter A, B, C, D, E, F, G. Okay, and the different letter indicate the distance, how far away this tolerance zone, okay, to the fundamental size, I mean the basis size. Okay, so this is the two systems. One is hole basis, the other shaft basis. They are the mirror image. Okay, so for example, the moment you see H7 K6 capital H, the capital H means this is the hole basis system. If you see the lowercase h, means this is the shaft basis system. So for H7 K6, you should refer to the table on the page 12. For the E9 H9, you should refer to another table on the page 13. Remember, on the topic 2 notes, we have two tables there. One is for hole, one is for shaft. So when you see the specification like this, then you should know where to refer to. Okay. And these two systems are exactly same. So for example, H7 K6, what is the equivalent specification in shaft basis system? Basically, it will be K7 H6. Okay. This is currently this is the H7. You have a H7 K6, but there's an equivalent specification. Is a H7 K6 is the current specification. The K7 H6 is the equivalent one. You notice just the letter switch over and you change the lowercase to uppercase to lowercase. Okay, for this one it's the same thing. I have E9 H9. That's my existing system. If I want to specify an equivalent system, that will be H9 E, something like this. Basically, these two systems are equivalent. Most of the time, we use a hole-based system. There's some reason, but sometimes we use a shaft-based system. Very special cases. Only thing like you know, one shaft fitting with fitting many pieces. You might need to use a shaft-based system. Otherwise, we always use the hole-based system. Okay, so how do we specify the fitting? Basically, when you're talking about fitting, two parties. One is a hole, one is a shaft. Just a general terms, General term. This hole could be a pocket. The shaft could be another square pieces. something like this, we're just using a general term. Say one is a whole female part, one is a shaft, is a male part. And when you fit together, I need to achieve certain fitting conditions. So how do I achieve that? You specify upper limit, lower limit, upper limit, lower limit for each of them. But you don't anyhow specify. You might not achieve your fitting condition. So the safest way is to refer to the standard, because they already work out the solution for you. You just need to take the specification from there and then use it for your own. That's the purpose. So for these specifications, then you can see here there's so many different specifications. Just to give you examples, all these are chosen fitting specification from the tables. For example, basic size 65 H7 G6. There's one look at this specification, I know this is the clearance. And if you're not so sure, you have to refer to the table. Remember in the table, we write down there, H7 G6 is a clearance. So from the table, you know this is the clearance. Okay, so where to get this value? From the table again. Remember, based on the nominal size, basic size 65, based on the specification H7 G6, you get the upper limit, lower limit for each phase. Right? And from here, then you can find out maximum size, maximum clearance, minimum clearance. The allowance just leave it. Okay, you don't have to bother so much. Okay? And then there's a G7H6. Basically, these two are the mirror image. And then from the table, you get another set of the data. And finally, you find out they are exactly the same because maximum and the minimum clearance are the same. So these two specifications, although looks are different, but they work exactly same way. That's what we are talking about, mirror image. There are two specifications. One is the whole basis, one is the shaft basis. Yeah, exactly the same. And you can do the same thing for the interference fitting and the transition fitting. Now, my suggestion for you is for the topic 2 calculation sure will come up for the test. 100%. And it's overbooked. And you have to do the calculation like this. If you don't know how to do it, those questions you won't score. It's simple, it's like this. So what I suggest to you is you cover the right side. You only see the first two columns. Then you go to see the table on the notes, page 12 and page 13. Try to do something. If you can get the same answers, then you are fully understand. Is it clear, class?
Yes, sir.
For the topic 2, please do so.
Very confusing.
If you don't do, you just listen to me, you won't get it. It's a very simple logic behind, but you need to hands-on. You need to do one run. If you do one run, I think it's very easy to understand, very easy to do. Just a simple plus minus only.
Can.
Alright, so give a try. You have to give a try. Huh?
Yes, sir.
Some students say, so simple, I can do it.
You start your face.
Guarantee you, the first time you're sure wrong. Okay?
Yes, sir. So my first time cry how?
Then it's a bonus. Okay, and this is the fundamental values. I think this one is just for information. This is not critical. And here, they mention our fitting is specified H9, E9. Okay, so basic size is 100, is given 100. Then from here you can get these values. All these value is from the table. Remember, there's two tables. The table you can refer to anytime, but you must know how to get the value from the table. That's the important part, important thing. Okay, so from here we can work out maximum clearance, minimum clearance. And one of the easy way to find this solution is like this. You don't have to worry so much. You just easy way out. Easy way out. I show you. Okay, so I want to find the maximum clearance. You just need to do the cross operation. These two minus what? I want to find out the minimum clearance. This value and this value minus what? Okay? Yeah. Cross operation. Okay? So you will see the result exactly like this. Right?
Yeah.
So means that remember, just need to remember whole minus sharp. Always whole minus of sharp.
Okay.
And you just need to do the cross operation, you will get the result very easily. Very easily. Okay. And the below one also same thing. You can just do it. You will see the result exactly
Also
same.
same cross method.
Yeah, same method. You can do same method.
Okay.
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 Yeah. You do this part. You will get
Can. You just give a me break.
Yeah. Let me finish off this question. I did very fast. Okay. We can go for break.
Okay, thank you.
Sorry. Rush. 11:05.
No rush.
And the question 10, you are given a diameter 10 mm connection pin, and you are given some information here, loose clearance fitting. Okay, based on the information given, you go to find from the table, no? Okay, so here is a 20, sorry, this table has a 20 mm. And the loose clearance fitting, based on loose clearance fitting, I get this specification.
How you get that?
Remember in the table, below each of specification, they have a description. Yeah, based on description, yeah, you find out this.
So
this
all this information I have to find from the table.
loose clearance fitting.
Okay.
You will find from the table. Now, once you have this specification, then I know the 20 mm. From the table, I get this value.
Okay.
And
cross,
yeah, then I do the crisscross, I get a maximum clearance.
Oh, okay.
So this is the overall procedures, huh?
Okay.
Yeah, something like this, huh?
Okay, thank you.
Now there's what's the limit size of a connected pin and the pin hole. Okay, so here you are given H7 G6 fitting. And the nose, this is the clearance fitting. And the same thing, you can find out upper limit, lower limit for each of us. Hole and the shaft.
Okay.
So here basically the thing is a shaft.
So this one do you use screenshot method also on?
So this is the same thing. Okay, there's a fitting here. So we can do the crisscross operation, and you will find out the maximum clearance, minimum clearance.
So this whole this topic is mostly this topic is mostly crisscross method, is it?
Yeah. Basically, for when you find out maximum or minimum clearance or interference, the same method.
So okay, can.
Yeah. They will test you either is a maximum clearance or minimum clearance.
But they won't test both one, man.
Sometimes it depends on transition cases. I don't know. That one is only set of papers. Huh?
Okay.
Okay, then the final answer they say must have times 2. For some students,
Why must I do?
yeah, they see the lengthwise movement y times 2. You go to C here. There's a two kind of a fitting here. Okay, you have a left side, this part, and the pin, there's a clearance here. Between the pin and the right side part, there's a clearance here. So the clearance we are talking about is between the left side part and the right side part. So this clearance basically is accumulation between this and the other one. So times 2. That's why we times 2.
So will that happen for every single time will be times 2, or is it only?
No, only for this special case.
So it's depending on the question, can be
Yeah,
times
yes.
3, times 4.
Yes. For most of the time, it's no need to times 2. For these specific questions, they need to times 2. Because there's a two fitting in one assembly. So you have to times 2. Okay, so they are talking about
Three fittings is like three.
they are talking about these two, the clearance between these two, left and right. But the left and right, you see here, the left and right never fit together directly, right? They go through the pin.
Yeah.
So the left part and the pin, one clearance. And the pin and the right side part, another clearance. So these two add together, basically times 2 lah, or plus add together.
So if there's let's say 4 clearance, it's like 4.
4 clearance, add together, add together, plus.
Add together.
Yeah, plus.
Then wait,
This,
why this
this times 2 basically is a plus.
Uh-huh.
1 plus 1,
Oh.
2 lah. Essentially it's a 2 lah.
Okay, okay, can.
Okay.
Okay.
Don't multiply, just about plus.
Okay.
Okay, so next, these are exactly the cases you are talking about. If I have a dimension accumulated like this, D dimension and the BC, 3 dimensions, BC add together, and there's a clearance here. There's a clearance here. So how do I find the clearance for these 3 dimensions? Basically 3 pieces, 3 pieces add together, and the maximum clearance means that D is a max dimension. Then B and then C minimum dimension, you will get 1 clearance. Right? That's a maximum clearance. How about the minimum clearance? When the dimension D basically is like a whole. D is the minimum size, then minus of B and the C maximum size. So you will get the clearance 0.15 and 0.65. That's the range of a clearance you are expected from such of a curated.
Okay, so wait up. Okay, thank you.
Okay.
Yep.
Alright, I think we can take a break now.
Okay.
Yeah, there's some very break out. There are so many things to cover. You very tight. Okay, take a, I know very tight today.
Okay.
Take 1 minute.
My phone.
11:20. Check out the item. You put your basket on the conveyor belt. Basically, the one is the belt. The belt can move.
You record for Chris or what?
Okay.
Oh, yeah. Also can, it's because I'm napping, that's why I record.
Every car has a timing belt.
The bell.
Yeah, timing belt.
Okay.
If your timing belt has problem, then your car should have a problem. Timing belt quite long lasting. Okay, so for the topic 3, there's a 2 parts. One is the bell, one is the gear. We're talking about this as a drive system. These are the things for you to deliver motion, to deliver the power. And this topic, I will go through the sum of questions on the belt. Because our test, our midterm test is only until the bell. If you look at it,
I love China.
So long ago, it's like
so
kindergarten.
you can see here.
Let me know you after that, your Thanksgiving.
No, but it's like the here.
Okay, so you can see here. We are going to cover the topic 1, 2, 3 until the belt. So the gear is not included for this coming up quiz on the weekend.
So the presentation can bring forward.
No, that one is another issue lah. We'll come back to discuss. Okay. So not really. Okay. So then I come back to here.
地址在那边不要做，那边打。
Sorry.
Okay. So there's a few questions here. Question 1 to 5 quite straightforward. Basically, you go through the notes. I think that you fully understand. I'm not going to cover. I'm going to cover is about topic 6. Topic 6 is a calculation. Calculation also easily come out. Might be this round or test, maybe second round, maybe the third round. Don't know. Who knows? Okay. So for this calculation, formula is given. But what I try to say is, when you do calculation, be careful. Be careful. So for example, they will need to find out the angle beta. Using this formula, please answer in radian. Because some of your calculator, there's a you have a switch between the radian degrees, right? So you have to make sure you are in the radian mode, Then you will give your answer. how do I know whether it's in the radian mode or not? Typically, radian is a very small value. One circle, 2 pi. 2 pi means 6.28. Right? Very small value. If your angle 360 degrees, so you see the numbers, you know whether you are in the radian or degree. Very easy to tell. For some children are careless. And you must have a radian, then come to this formula, you are correct. Pi is a radian. Yeah? Pi representing 180 degrees. And the 2 beta times this value, that's correct. Radian is correct. If you don't pay attention to it, your answer here in degree, then you are in trouble. You won't get the correct answers. So this is the thing I want to highlight. But in the radian, okay, so here is a 1 pi. 1 pi is 180 degrees. Very easy to remember. You have a table here, you put a pi here, you put a piece of a pi here. Okay, so it's 180 degrees. 180 degrees, right? So 180 degrees is 1 pi. Very easy to remember. Some students say, how to remember? Very easy to remember. Your second pi or whatever pi for the 1 pi, 180 degrees. So it's a conversion for you to do conversion. So how do I? Sometimes they ask you, give me an answer after radian, give me an answer in degree. So for the radian, convert to this one very easy, huh? This value times 180 divided by pi. Divided by pi. Then you will get a degree. It's so simple. Right? So from the degrees, convert back to there, it's so easy. Divided by 180 times pi. Because 1 pi equivalent to 180 degrees. Right? Okay, so this is the things I want to bring you to the attention. Huh? Because after that, you need to go to find out the overall length of the belt using this formula. In this formula, you have to plug in the value, this 2 angle value in radian. If you don't use a radian here, answer wrong again. Answer wrong again. So that's the things I want to highlight now. And finally, you will get this one is in terms of mm. So the overall length of a bell is about 1.872 meters. Because millimeter divided by 1,000 is a meter, so it's 1.8 meters. Important thing here, let me repeat. This one you must have in the radian value. You must have in radian value. That's the thing. Okay, all the formula is given. All the formula is given. But yet again, some students make mistake because they didn't watch. Just now I mentioned, when you do the calculation, come to this formula here, this 2 formula here, please using radian. Please using radian, then you will get the correct. Alright. The next is how to find the speed of a large pulley. Okay, based on the diameter or radius of a pulley, there's a driver and driven. There's 2 pulleys. Okay, so basically 2 wheels, and they are located in different speeds. The larger one slower, smaller one faster. It's always like this, the larger one. Because one tall person, one lower person, if you work at the same speed, then the tall person can work slowly. The smaller person has to work very fast, then they catch the pace. Okay, so you can see here, small n representing the rotational speed. We put S small, L large. Then the speed, basically smaller pulley will spin faster. So on the right side should be DL versus DS. That's the opposite. Just opposite. Because NS smaller one expected to be faster, so right side DL, right? Because of that bigger diameter. So left and right is the same proportion, right? So the moment you get this correct, this formula might not be given because so straightforward, might not be given. So once you have this correct formula, then you get the answer correct. And sometimes you will consider 3% speed loss, because a belt drive is not a positive drive. It's based on the friction. So during the drive, certain speed will be lost. So you just discount by 3%. Actual speed is around 1.4, something like this. So calculation wise, quite straightforward. And then yet again, you need to do a practice.
So it's always 3%.
No, given.
Or given, I follow. Oh, okay.
You see what's the given?
Oh, it's like 2%.
Okay, so this is another cases. The belt can be open drive, can be cross drive. Cross drive means the belt will run in cross way. So there's two different ways to drive. Then the formula will be different. So you have to see the question carefully. And you will be given two formula, two set of formula. So you must see the question, whether it's open or closed. Then you select the equation accordingly. Again must put inside the radius. Okay. The next, then you can use the same formula here. You can use the similar formula, because here has to be in the radian. Let me repeat again. Radian. Okay, then you will get the answer 1879. The final part is about speed of a belt. The belt will traveling at a speed. Okay, so what you need to do is using this formula now. This is secondary physics. Okay, omega angular velocity times the radius. Omega basically 2pi n divided by 60. N is a revolution per minute. So revolution per minute divided by 60 is a revolution per second. One revolution is 2pi. So it's a very simple formula now. One revolution 2pi. 360 degrees. Okay, so this formula plug into here, then you get the answer. Because 2r basically diameter, 2r is the diameter. R is the radius. And then using this formula, you can find out the velocity density. The velocity is 4,600 millimeters per second. So the belt traveling pretty fast. 1 second they can travel by 4 meters. Okay, so this is about the calculation of the belt. The gears we will discuss after I come back. After I come back from the trip. Okay.
What? Sorry. You also keep that.
Okay, class, let me repeat. So now I have covered a topic 3, the belt. Okay? And the gears revision question, I will come back on the week 16. Week 6, we will cover. Alright? And let me repeat. Next week, Friday, don't have a class.
What? Next Friday don't have class, why? Oh, you going business trip, right?
Yes. Let me repeat.
So you go where?
So these two weeks.
So you go where?
Germany.
Germany.
Okay, so these two we will cover now. Just now I mentioned the question already covered. But now come to the project work. Let me repeat the project work. Let me highlight the okay. The project work, we are going to start project processes. Until now, we are doing the planning only. You know, we start off a project, kick off the writer, followed by this Gantt chart. All this is the planning only. So now, this week, next week, and the week 5, we need to do start doing the project, real project. Okay, so the details you read through. So what are the things we need to do? Let me highlight. What are the things you need to do for the next 2 weeks? Hello, class. For the practical lab session, for the next 2 weeks, what you are supposed to do, I'm going to highlight. For the lecturer, topic 2, topic 3, please go through. Please go through and do all the tutorial questions. Okay? And all the quiz, topic quiz, please complete. Now we come to the project work. The project work, okay, so we need to get started. We need to get started here. And all these things, we don't have to repeat. Basically, it's the same thing. And first thing you need to do is, define the problem. Remember, we have a dense form. But now we need to revisit the definition of problem. Because we need to do a bit more. In the week 1, we already jump start with the write-up part. Not enough.
Right.
It's a time for you to build up the content. Okay? So, define the problems. Then there's a procedure for you to do so. This is the things that we have to do now. Okay? First thing, research work. Second thing is you need to get the data, the background information search. A bit details. Please do so. They will show you how to do the background search.
I don't like.
And you need to find out a solution, talk to the people with more experience. This might be quite hard, but then you need to do this is a background research and a plan. They show you how to do that. Then after you have done so, you need to specify the requirement. Specify the requirement. So the first thing you need to do is design requirement. Okay, so I have done the background information, searching, understand the existing solution. So the next one is design requirement. So this one you need to do next week. Hello class. Next week you need to do this one, and you need to submit. This is the week 4. Next week lab sessions. Okay, so the next week we don't have a class, but you need to do this one. Based on the understanding of the market and understanding the requirement, then you work out a list of expected features in Apple Pay. So this is the next week. Yes, writing in the word. And probably sometimes you give
just do together with the last week.
yeah, you add on the things. Okay, so for example, geometry, the size, you can write expected size of Apple
So
pillar.
must include all of this shit, all of this stuff.
No, this is the recommended values, recommended features.
So basically it's a must if you want to score.
So for your case, you have to change a little bit. So this is the week 4. Week 4 lab work. I write that here.
No, this is in the collect more, bro.
Bro, you want the bet, right?
Capture, phone capture.
Okay, so this is the week 4. You need to do this one.
I know. I'm just sending.
Especially cheese.
You are
Yeah, you want to but you
I am the person that just told you.
after that you ask.
Week 4, next week, we need to do this part. And you need to upload to
Look at him. He's trying to fight us. Where is time? I don't listen to entertain.
Okay, now, how about week 5? Okay, one more week. Week 5, we need to idea generation. So idea generation means there's a brainstorming.
Hey, don't touch iPad.
You need to create some hand drawing, some illustration. Okay. Hello.
Even wow.
And
That's when you take grade.
hello.
That's for me, ah.
Yeah.
No time, ah.
So idea generation, how do we do it? I will give you some approach. Okay, so you read through the information here, but you might not still have ideas what we should do. For example, how to conduct a brainstorming session, how to do the sketching. Some of you say, I really don't know what to do. I see through the existing solutions, I don't know how to do it. Okay. Okay, so for the week 5, later I will forward you this PowerPoint. The approach we are talking about is a Scamper. Scamper is the way for you to do idea generation. There's a many ways to do idea generation. So Scamper is a very practical solution. Okay, so you go through.
This is not
This is not inside. I will give you this PowerPoint. Don't worry. Okay. So this is a simple illustration. What is the Scamper do?
Okay,
What does Scamper do? So
What is the one? This is portrait.
for the week 6, we are going to do the idea generation.
Wow.
So these are the basics. Using the Scamper to create a new ideas of a micropillar. Then you need to write up, you need to have some drawings, simple drawing. Then you submit to the Blackboard. Okay, so this is the week 6 homework.
I thought you were here week 4 and week 5.
No, sorry, so this is week 5. Sorry. You're right.
Each I got listen.
Yeah, you're listening. Very good.
Thank you.
Okay.
Hey, find your language.
Let me summarize 2 things.
So which side was the
For week 4,
triangle?
specification. That means after you understanding the market, you do the background information searching. We are going to develop specifications for your application. So this is the things we are going to do. We are going to do it here. Just now I mentioned. This is week 4. Okay. And this thing basically is write down in a Word document. You can continue with your week 1 work. You can continue from there. Okay. But you want to create a new file also okay. Then week 5 is the idea generation. Idea generation means you come out with some illustration, some ideas. These ideas as using the Scamper is the approach. You see? Any questions? Class? Is it quite clear? So I think today I will end here. And I will mark attendance.
Yes.
Almost?
Which also don't have.
Almost?
Oh, no.
Different group.
You're looking at the wrong website.
There are so many groups.
You've seen you.